In today's lesson, we're going to start talking about expected value. And expected value is a topic that is very useful, and it's used whenever you're in a situation where you could either win or lose money or something that has a value to it based on the likelihood of something happening. Okay. And so that's the reason why we're doing it with all the probability stuff. But the thing that you need to realize is expected value is not a probability. Okay. The thing you need to know about expected value is it is kind of what the name of it is a very good indicator as to what it is. So expected value is a value, something that has a value to it. So a lot of times you'll hear problems that involve money, and it's how much you're expecting to get. So to kind of put that together, what expected value tells you is the amount money wise, or if you're not talking about money, it's going to be something that has a value to it. So it's the amount that you should expect to get on average. So that's something that's really important here is you've got to realize this number is an average. Okay. So it's the amount on average you would either win or lose, because it could go either way in some of these situations. The amount on average you would win or lose per game, per time that you do whatever this is. So if you're playing a game, it'd be each time you play the game, if you played this game a lot. So in order for this number to actually play out, you would have to do whatever this is. So play the game over and over and over and over and over a lot of times. Okay. And so kind of putting that together, because it's a rather lengthy definition, expected value is how much you would expect to get on average per game if you kept playing that game, which, if you're a person that is playing a game where you could win or lose money, that's going to be something that's going to be really good to look at and concentrate on. Okay. And so we're going to learn how to find expected value. So if you're playing a game and you're trying to figure out, if I keep playing this game, how much am I expecting to win or lose, kind of in the long run? And that's going to be something that's good to know. So to actually find expected value, and they'll use the letter E for the expected value. So E stands for the expected value. It actually has a formula to it, and I'm going to help you kind of understand the formula. So, as you can kind of probably think about or imagine, to be able to find how much you're going to end up winning or losing on a game that is based on the likelihood of certain things happening, you're going to have to imagine every way that you could either win or lose. Okay. And so, what this formula actually does, you're going to see you have an A and a P in that formula. The A is actually what's called the payoff for a certain event. So, what payoff means is it's how much you're either going to be winning or losing. If this happens, how much am I going to win? Or if a different scenario plays out, how much would I lose? Because there's certain games that you could lose money. So the A is kind of like how much you're either going to win money wise or lose. So how much you win or lose. Okay. And so what you're going to do is you're going to imagine each scenario separately, and you're going to take how much you're going to either win or lose for that particular event. And then you're going to notice these are being multiplied to P. And P is the probability of that scenario happening. So the probability that you would win that much money, or if you're going to lose, it'd be the likelihood that you would lose that much money. So it's the probability of that particular event occurring. Okay. So What you're going to do is imagine every scenario, take the payoff for that event times the probability of that event happening, and then you're going to add it to any other scenario that could happen. Okay, so you can see how this plays out. We're going to go ahead and do an example. So number one, it says a die is rolled. You receive $1 for each point that shows. What is the expected value? So if you played this game over and over and over and you kept rolling the die and you get $1 for each point that shows, how much would you either win or lose in the end? And now notice, if you kind of look at this problem, there's not really a scenario where you end up losing money. So this would be a game that you definitely want to play, okay? But to find how much you would end up in a sense gaining overall on average, you would have to do the expected value. So to find the expected value, you're going to imagine every possible scenario that you could win, because remember, you can't lose in this game. All right. And so the way that you win is you're going to get $1 for each point that shows. So one way that you could win is if you roll the die and you roll a 1 on the die. Okay, so that's one scenario. So that's kind of like this part right here, that first part of my equation. Plus, well, another way that you could win is, well, if you roll the die and you roll a 2, then you would win a different amount there. And then another way that you could win is you could roll a 3 plus, I could roll a 4 or a 5. So notice there's 6 sides to a die. So there, because of the way that this problem works out, there's going to be 6 different scenarios I have to look at. And so there are my 6 things that could happen. Okay. And so notice I just kind of put blanks, and remember, you add up all the different scenarios. All right. So let's look at this first part. So if I roll a 1, then how much would I get as a payoff? Well, I would be winning, and you get $1 for each point that shows. So since you would just have 1 point showing, you would win $1. So the payoff would be $1. And then we multiply that times the likelihood that that would happen. Well, what is the likelihood that you would win the $1? Or in other words, what's the likelihood you would roll a 1? Well, there's only one side of the die that has a 1 out of the 6. So there's a 1 out of 6 chance that you would roll that 1. And so that's that first scenario. Well, what if you roll a 2? Well, the payoff would be, well, you get $1 for each point. So you'd win $2 in that case. And the likelihood of that happening, well, there's only 1 2 on the die out of the 6 sides. So you have a 1 out of 6 chance of rolling a 2. And then you keep going. So if we roll a 3, we would end up getting $3, and the likelihood is a 1 out of 6 chance, because there's just 1 3 on the die too. And then for the 4, you would win $4, a 1 out of 6 chance there. For the 5, you'd win $5 times the 1 out of 6 chance for that. And then the last one, you would win $6, and there's a 1 out of 6 chance there. Okay. And so after you figure out each scenario individually, you're going to multiply the payoffs times the probability of each, and then you just add what you get. And this is one where you could, if you wanted to, you could just straight type it in your calculator, and it'll give you the answer. So if I do this, I end up getting 3.5. Okay. And remember, this is money. Okay. So let's go back and review what this number tells me. So this is technically my expected value. All right. And this is telling you the amount on average you would win or lose per game if you played that game a lot. So if I just started rolling that die and I started writing down, what I won each time, and then I averaged my winnings, remember that's an average, then it would come out to be around $3. This is what this number means, and 50 cents. So technically, if you played this game over and over and over again, so in other words, a lot of times, so if you play a lot, okay, this means that you should expect on average to win $3.50 per roll. Now, if you kind of think about that, is there ever a time that you can roll the die and you would win exactly $3.50? No, because there's not a 3.5 on the die. But that's the reason why you have to understand that this is an average. So, like at one time you might roll it and get a 3, another time you might roll it and get a 4, you might roll it and get a 2, you might roll it and get a 5. But if you start averaging up how much you win, then it'll average out to be that you've won about $3.50 per roll. Okay, so that's what expected value is telling you, is how much you would expect to get or lose, if it's a scenario where you could lose, on average. Okay, and so the reason why I knew you would be gaining, other than just kind of thinking about the problem, is because the expected value is positive. If we got the expected value and it ended up being negative, that would actually mean that you're losing that much on average, which is not a good thing if you're playing a game with money. Okay, so let's look at another scenario, because there's all kinds of things that involve expected value. Okay, so a roulette wheel that you would see somewhere like maybe in a Las Vegas or a casino, that is something that deals with expected value, and it's good to know. All right. So it says there is a roulette wheel numbered 0 through 36. You can bet on any number other than 0. Okay. And so a roulette wheel is it's a wheel, and it's got colors on it. And then this one in particular says that it's got the numbers 0 through 36 on it. And what happens is they spin it, and then a ball goes around and around and around. And if it lands in the slot, that if you put a bet on a slot and it lands in your slot, then you actually win. Okay. And so let's say that you bet $1 on the number 23. That's your favorite number. Okay. If the ball stops in your slot, then you actually win $36. All right. So what we're going to do is we're going to find the expected value of this game. So in other words, how much should you expect to win in the long run if you played this game a lot? All right. So if we kind of think through it to find the expected value, we've got some situations where we could win, and we actually have some situations where we could lose. So let's start by thinking about the situation where we could win. All right. So if we win, then how much would we win? Well, there's two ways to think about this. And I'm going to kind of help you out with kind of thinking about both ways. So we're going to do it one way, and then I'll show you another way to think about it that'll actually get you the same answer. Okay. So one way to think about it is, well, first of all, you had to bet $1. So you've already technically lost $1 every time you play. Okay. But if you win, then you get $36 back. Well, if you kind of take away the dollar from that you had bet, then technically you only win $35 if you win. Okay, because we took away that dollar that you had bet to begin to even play the game. All right, so that's technically the payoff that you would get, how much you would get if you won. And then remember, you have to take that and multiply it times the likelihood that you would win. Well, if you've only bet on one number, you've given yourself one chance out of, well, how many numbers could the ball land in? Well, there's 0 through 36 slots. So think about how many slots there would be for that ball to land in. Well, 0 through 36 is technically 37 slots. So because you've only bet on one of them, you have a 1 out of 37 chance of the ball landing in your slot and you winning. Okay. So that's how much you would win and the likelihood that you would win. And then you have to remember to add that to any other scenario that could happen. Well, the only other thing that could happen is if the ball lands somewhere other than your slot. So that technically means that you would lose. Okay. And so remember, to lose means the ball does not land in your slot. So the ball does not land in your slot, or the number 23, because that would be the one that you had bet on. Okay, so if that doesn't happen, then that technically means that you would lose that dollar you had bet. So because you would lose, you have to put a -1 with that. So you'd technically be losing that dollar. And then what's the likelihood that you would lose? Well, we've already included the fact that you've bet the dollar there. So, well, we just have to look at all the other scenarios. Well, you would lose the dollar if it lands in something other than your slot. Well, how many slots did you not bet on? Well, there would be 36 slots out of the 37 that you would not have bet on out of the 37. So you have a 36 out of 37 chance that you would lose the dollar without, of course, winning any money. All right. And then that's every possible thing that could happen. And so then again, you just type it in. So you could multiply these and multiply those and then add those numbers. And when you do that, you end up getting -0.027. Okay. Now remember, this is money. And this is what you get for the expected value. So what this technically means for you, what does this mean for you? Well, money-wise, the smallest that money goes is this spot right here. So I'm going to round to that spot. So that would technically be about -0.03. So that's 3 cents if you think about it as money. So for you, what this would mean is you would lose on average 3 cents each time you played. So you would lose 3 cents on average each time you play. Okay. So then what does that mean for the casino? And we know that you're losing 3 cents because it's a negative. So then for the casino, that would technically mean that they are getting or gaining 3 cents on average from you. So they are gaining or winning 3 cents on average. Gaining 3 cents on average per gameplay. Okay, so if you think about the people that play this game, there's a lot of people that play this game, and 3 cents isn't much, but if you're playing it a lot, which we talked about, expected value is if you keep playing this game a lot, then those 3 cents per game will add up, and that's actually how the casinos gain money. All right. And so something that I want you to kind of be aware of that goes with expected value is this next question. It kind of feeds off of the same problem. If you played this game 1,000 times in one day, which some people do, how much should you expect to win or lose based on the expected value? Well, if we're talking about you as the game player and you're losing 3 cents approximate. So remember, this is an approximate number because it's kind of based on your chances. If you're losing 3 cents per game on average, then if you ended up playing, missed my A here. If you ended up playing this game 1,000 times, then how would you figure out how much you would end up losing overall? Well, you would take 3 cents, so you could write it back as your decimal, and you would multiply that times 1,000 because you're losing 3 cents per game. And if you play it 1,000 times, then you would just take that and multiply it times 1,000, however many times you play that game. So if you played it 1,000 times, then you would expect to lose, that ends up being $30. So you would lose, and remember, this is an approximation, you would lose $30. Okay, and so if you're kind of planning on going there to win money, that would probably not be a very good game to play just because it's kind of set to where you lose. All right. So the last thing that we're going to look at is, when people offer deals to people, it sounds really good. And so, it's always good to look at the math behind it. So this, I've just kind of made up a problem so we could look at what happens when somebody offers you a deal. How can you look at it in an expected value sense? All right. So it's talking about a newspaper route. And it says Joseph was collecting from his customers on his newspaper route. One of his customers offered him a deal. The customer would place 3 $1 bills, one $5 bill, and then one $10 bill in a bag. And of course, Joseph couldn't see inside the bag. And then Joseph would reach in and take one bill from the bag and get paid that instead of his regular $5. So if you were Joseph, should you take the deal? Should he give up his normal, because it says he normally makes $5? Should he give up his normal $5 that he would get to take this deal? Okay, well, let's think through it. So this is a problem where you would want to find the expected value over time. Okay, so remember, there's 3 $1 bills. So I'm going to kind of draw this out so that we can see what's going on. So there's 3 $1 bills in this bag. There is one $5 bill. And then it says there's one $10 bill. Okay. And so that's all the bills that are in the bag. All right. And we're going to find the expected value, how much he would expect to get if he decided to take the deal and just draw from the bag each time. And we're going to figure out, should he take that deal? Well, what are all the different scenarios? Well, if he reaches inside the bag, it's going to be either that he gets $1, gets $5, or gets $10. So we've got 3 different scenarios. It's going to be if he gets the dollar or one of the dollar bills, plus if he reaches in and gets the $5, plus if he reaches in and gets the $10 bill. All right. So if he reaches in and gets the dollar, then the payoff would be $1 because he would keep the dollar. What's the likelihood that would happen? Well, there's 3 $1 bills out of the 5 bills that are in there. So he has a 3 out of 5 chance that he would get a $1 bill. Plus, well, if he reaches in and gets the $5 bill, he'd have the $5. And what's the likelihood that he would get the $5 bill? Well, there's only one $5 bill out of the 5 total bill. So he has a 1 out of 5 chance of getting a $5 bill. And then the $10 bill, well, if he reached in and got that, he'd win $10. And then the likelihood of that happening is there's only one $10 bill out of the 5. So he has a 1 out of 5 chance that he would get the $10 bill. All right. And so that's every scenario. So when I type this in my calculator, I end up getting 3.6. So if we think about that as money, he would end up getting, so you got to think about this because it's talking about money, he would end up getting $3.60 on average if he decided to take the deal. So should he take the deal? Well, if you compare that to what he normally gets $5. It would be a big no. Okay. So you would put no, he should not take the deal. And well, why? Because it does say to explain. Well, the reason is because if he took the deal, he would, and you could put this a couple different ways. You could actually do the math and figure out how much less he'd be earning, which you would just take the 5 minus the 360, and you would end up getting $1.40. So you could say he would earn $1.40 less on average. Okay. Or you could just say if he took the deal, he'd be making $3.60 on average rather than his $5. So as to how you put it, it kind of depends. You can go a couple different ways. So I'll write it actually doing the math. So because if he took the deal, he would make $1.40. See, remember you just subtract. Find that. less on average, which is not a good thing. And so he would stick with his normal $5. All right. Well, hopefully this has been at least an interesting lesson. Let me know if you have questions. Have a good day.